In this demonstration lecture for C-SMART, we will cover parallel indices. We will look at their purpose, their construction on charts and radars, and how they are used in practice. A parallel index is a line constructed by the navigator to be used in conjunction with radar to ensure safety. The use of parallel indices helps to increase navigational safety by providing the user with a means to continuously monitor ship's position relative to track and to navigational dangers. The United Kingdom's Maritime and Coast Guard Agency says that investigations into cases where vessels have run aground have often shown that, when radar was being used as an aid to navigation, inadequate monitoring of the ship's position was a contributory factor, and that parallel index techniques provide the means of continuously monitoring a vessel's position in relation to a predetermined passage plan and would, in some cases, have helped to avoid these groundings. The reason PIs are particularly useful is that they don't depend on any external radio signal. GPS, for example, is subject to both environmental and deliberate interference, and the current extent and direction of the positional error on a GPS system is difficult, if not impossible, for the operator to know. When using the ship's own radar, if the system has been correctly checked, the errors are known: the index error along the radar bearing and the rotational bearing error. So with a correctly calibrated and checked radar, a parallel index can provide reliable positional information independent of external sources, and can be used confidently in restricted visibility instead of visual means if the operator is comfortable with its use. Now we will construct some parallel indices on this chart. First, select a point of land or navigational mark with good radar reflection. Cliffs, Raycon beacons, piers and jetties are excellent points. Those surrounding by drying areas or shallow slopes should be avoided. Lay off a line parallel to the planned track that touches the point. Measure the distance between planned track and the line that touches the point. This will show the required position of the line on the radar screen that will indicate whether or not the vessel is on the planned track. When you transfer the planned line onto the radar, you will see something like this. As long as the index line, in yellow, touches the selected point, the vessel is on track. In this case, the indicated course over the ground is 299, so as the vessel moves slowly to port of the planned track, the echo of the selected point will move further away from own ship and therefore away from the line. If course over the ground is setting the vessel to starboard, in this case by a larger amount, the land echo will move closer to own ship than the line, quickly indicating you are off track. However, knowing you are off track doesn't help in knowing how much safe water you have. In fact, the main purpose of PIs is not to tell you that you are on track, but to provide an instant indication of safety in relation to the available navigable water. This is done by creating no less than and no more than PIs to enclose the ship's track on both sides. First, identify the closest points of danger on both sides of the track. Then, using the same technique for the on-track PI, lay off lines parallel to the planned track and measure the distances. It's important to remember that you are referencing to the on-track index line so that the distances are measured from the point you are running the index line on, not the planned track. The other thing to remember here is that when you construct these lines, there is usually a large amount of water you would normally be safe to enter that the index lines prevent you from using. They simply create a corridor down which you can prove it is safe to transit. This can be especially relevant when manoeuvring room is important, where the use of safety ranges and further PIs may be necessary. Now we can see that with the no more than and no less than PIs shown on the radar screen, even though we are off track, we can instantly tell that we are safe, and by using an offset EBL and VRM on the PI's mark and measuring the distance to the clearing PI, we can also tell how much safe water we have in the direction of the way we are drifting. PIs can also be used for planned wheelover points in precisely the same way that a wheelover visual bearing is used. In general, it's best to use the point on which you will be running the next leg's PIs as the wheelover mark, as it collapses off-track errors in the same manner as using the wheelover bearing of your next head mark does in visual pilotage. Simply select the point for the indices, in this case the northern edge of a small island, and measure the offset of the wheelover position using the new alignment of 270. In this case the mark needs to be 4 cables offset at the turning point. On the radar, the wheelover PI will look like this. The navigator is monitoring for when the northern edge of the most distant of the two islands touches the PI. When it does, it's time to alter for the new course. That completes the short demonstration lecture. Hopefully you will now be able to correctly answer these questions. Use the video controls to go back to any section you feel you need to cover again.